Okay, so this problem reads, a hydrated potassium carbonate has the formula K2CO3H2O, XH2O. A 10 gram sample of the hydrated solid is heated and forms 7.93 grams of androgenous salt. So A says to calculate the number of moles of water in the hydrated sample. So since your initial sample of this has 10 grams, and then once you heat it and the water evaporates, you have 7.93 grams of androgenous salt. The amount of water that you have in grams is simply 10.0 minus 7.93, which equals 2.07. So this is 2.70 grams of H2O. But it asks for the number of moles of water, so take 2.07 grams of H2O, and to find the amount of moles you have to multiply it by the reciprocal of the molar mass, so times 1 mole over the molar mass of water, which is 1.02 times 2, because that's hydrogen, there's 2 hydrogens, plus 16. And this is approximately 0.115 moles of H2O. So that's the answer for A. B, it says to calculate the number of moles of androgenous salt that forms. So for this one, you do a similar thing. Just to clarify, so this is the hydrate of potassium carbonate. This part is water, and this part is your androgenous salt. So again, it says that 7.93 grams of androgenous salt forms. So you again do 7.93 grams. You multiply 1 mole over the molar mass. So this is 39.1 times 2 plus 12.01, which is carbon, plus 16 times 3, which is oxygen. You can see this is grams, so grams cancel out, and you get approximately 0.0574 moles of the androgenous salt, which is K2CO3. So that's your answer for B. For C, it says to determine the formula of the hydrate. So we're going to do this on the other side. So for this one, for C, to determine the formula of the hydrate, you have the amount of moles of H2O and the androgenous salt. So just to review, you have 0.15 moles of H2O, and you have 0.0574 moles of K2CO3. So to find the formula, you have to find the whole number ratio of these two moles, because again, your formula for the salt is you have let's do this in blue, blank K2CO3 X H2O. So these are the two coefficients that you have to determine. So to do this, you're going to take either amount of moles, and you're going to divide either by the smallest number. So in this case, it's 0.05. So you divide this by 0.0574. You divide this by 0.0574. So this is obviously 1. And when you divide this, you get approximately 2. So this is the nearest whole number ratio. So again, because this is for K2CO3, your equation is going to be 1 K2CO3, which you can just put K2CO3 dot, and this is your coefficient for water, so 2 H2O. H2O. So this is your equation for C. And then for D asks, how could you determine when all of the hydrated salt has been converted into anhydrous salt? So in the problem it said that you had K2CO3, 2H2O, and that is your hydrated salt. And then it heated it, and it evaporated the water, and then you're left with the anhydrous salt. So to determine when all the hydrated salt has been converted into anhydrous salt, you would simply heat the mass until there was no longer a change in mass. So in other words, you'd heat the sample, and when there's no longer a change of mass, meaning when you know that all the water had evaporated from the sample, then you would know that there was only anhydrous salt left. So again, you would heat the sample until there is no longer a change in mass. Thank you.